Okay, so here's our LeetCode problem for the day, number 35, search insert position. Okay, so quick review of indexes before we solve this problem. Indexes is basically the position each element holds inside a list. What is an element, you ask? Elements are the numbers inside the list. So 1, 3, 5, 6 are all elements. The index is the position of that element. So number 1 is in the 0 index, number 3 is in the 1 index, number 5 is in the 2 index, and number 6 is in the 3rd index. So that's basically what it means. Now what the problem is asking us to do is, given a list of numbers and a target, let's say 5 in this case, we need to return the index of where that number lies. So like we mentioned, 1 is in the 0 position, 3 is in the 1st position, 5 is in the 2nd position, and that's what we outputted. Now there's another case that the number inside the target is just not inside the list. In that case, you need to output where it should be if it were sorted. So obviously in this sequence 2 would come between 1 and 3. Since 1 is in the 0 position, 2 needs to go in the number 1 position, in the number 1 index basically. So it will go right between 1 and 3, and that's what your program needs to output. This one also mentions that our algorithm should be with the time complexity of log n. If you don't know time complexity, do not worry about that. We'll get into that later. Okay, so in order to solve this problem, we need to use something called a two-pointer technique. Now, I don't know if this is the exact terminology for it, but I'm self-taught and I didn't go to university, so I guess I can call it whatever the fuck I want since it works. Alright, so let's get into this. Okay, so here's how it works. We're going to initialize the left pointer and a right pointer. Let's say that the left pointer is pointing to the index of 0 and the right pointer is pointing to the index of 3. We first have 3 conditions we need to check. We need to use this concept of a midpoint, so for that we're going to find the middle of left and right. Best way to do it is 3 plus 0 divided by 2, which should give you 1.5, which gives you 1. In computer science, you don't round up even if it's a 5 or a 7 or a 9 in the decimal place. You always round down to the floor, which is 1 in this case. So our middle is pointing to the first index, which is number 3. Now you want to use this middle number to compare to the target. There are 3 things that could happen. First, that the target is equal to the index position, or the target is more than the index position, or the target is less than the index position. So we're going to look at the first scenario where the target is equal to 3. In this case, you would just return 1, so you return middle. That's pretty simple. So here's the second scenario where 5 is the target. So 5 is greater than 3. We can safely assume that anything to the left of this is all garbage and we don't need it. So what we need to do is now update our left pointer and move it to the right of this little barrier I made over here, which could be written as middle plus 1. So over here, middle is 1, 1 is over here, and then plus 1. So you're moving it to 5 here. So now it's pointing to 5. Your new index is 2. And again, you have to update your middle since your left pointer has changed. So to update our middle, we need to do 3 plus 2 divided by 2, which should give us 2.5, and it rounds down to 2 again. So it's pointing to the second index in our list, which is number 5. Now you do the same thing, you check if 5 is equal to the target. In this case it is, in this case it returns 2, which is correct. Okay, now in this scenario our target is 1, which is less than the middle, which is number 3. So we can safely assume that anything to the right of this is all garbage again, since we already checked for 3, that's included. So what do we need to do now? We need to update our right pointer, and we're going to do that by moving it to middle first and do -1 because we need to move it over here. So we can write it down as middle -1, which moves it to 0. So our new pointer to the right is 0, which is also the same as the left pointer. So we can safely assume that you can just return 0 at this point since the pointers are matching to the same area. Lastly, we can have something as a target that's not even in this list. It follows the same logic we were going through. So first you would check middle is less than target, which is 4. So you would totally ignore everything on this side of the list, update your left pointer to this number 5 here, and your new index would then be number 2. Your middle would change to 2.5, which is then 2. So 5 is our new middle, you would check again. In this case, your middle is greater than the target, so you would move your right pointer to the left now. In this case, you would have to move it all the way till here, and you can totally see that your right pointer is at number 1. So you can see at this point that your left pointer is greater than your right pointer. In that case, you need to break this loop and you just need to return left, which would be the correct answer in this case. You're telling us that number 4 fits in the second index of this problem. Since 1 is at the 0 index, 3 is at the first index, 4 needs to be in the second index, so that's your answer. I know all this is confusing, but when I'm gonna get to coding, I hope this clears everything up. Alright, so let's solve this problem. First, we're gonna initialize a left pointer, which is to 0. Then we're going to initialize a right one, and we're gonna put the length of the numbers -1. Okay, so we need to put -1 because length starts counting from 1, so it's 1, 2, 3, 4, whereas we need up to 3, not 4, because in computer science you count from 0, 1, 2, 3, which is 4 elements. A little bit confusing, but you get a hang of it after. Okay, we're gonna open up a while loop which checks if left pointer is less than equal to the right pointer, and if it is not, in that case it breaks the loop. Alright, so in this we have 3 conditions. We first want to check if num's middle is equal to the target, in which case we just return the middle number. Now you probably see we haven't defined middle. I will do that inside the loop right now. And you want to put brackets, otherwise it would divide first. So left plus right divided by 2. That would give us the middle number. So you're checking if it is a target. In that case, it just returns back the middle index. If num's middle is less than target, then you would want to move the left pointer to middle plus 1. And same for the right one, but in this case we can just put down else right equals middle -1. So you've checked all these conditions and it keeps looping through essentially. So if it's less, it will move the left pointer to the right, and if it's more, then it's going to move the right pointer to the left. So this one's basically going to keep running in a loop essentially. So if the target is more, then the left pointer is going to move, and if the target is less, then the right pointer is going to move until left is more than right, which breaks the loop. And outside the loop, we just want to add return left, as we discussed on the explanation part of the video. And that's it. This should work. Good. Let's check the time complexity because it needs to be log n, I mean. Yeah, here you go. It beats 100%. That's great. Okay. That's all for this one, and I'll see you on the next one, dipshits.